Hi there, everybody. This is lesson 321. We're going to be looking at similar triangles today. Here you see some similar triangles, and let's just review what we know about similar triangles. We've been talking about similar triangles ever since we did dilations in that first lesson. When you take a figure and you dilate it or enlarge it, what you get is a figure that's similar, in other words, the same shape but different size, than your original figure. Okay, so that's all similar really means is that they have is two objects that have the same shape. And you can see these triangles here, they have the same shape, and there's some things we know about similar triangles. First of all, in order to be similar, these sides have to give you the same ratio. So we've got 6 over 3. 6 and 3 are corresponding sides, and that ratio is 2. 8 corresponds to 4. That ratio is 2. 10 corresponds to 5, and that ratio is also 2. So those ratios, when you have similar figures, those ratios will always be the same. And it won't always be 2. Sometimes it's 3, sometimes it's 0.6. But as long as all three of those ratios are the same, we know we've got similar figures. We also know that the corresponding angles are the same. For example, angle A has to be the same as angle X. The measure of angle B has to be equal to the measure of angle Y. And the measure of angle Z has to equal the measure of angle C. These two angles are the same also. Just when you enlarge a figure, it doesn't change the angles. It changes the lengths of the sides, but again, not the angles. So in order to know that triangles are similar, we have to know all of this information. We have to know that those three ratios are all the same and that these angles are the same. Then we know that triangle ABC is similar to triangle, now what order should we put these points in? Let's see, I started with angle A. Angle X corresponds to A, so I'm going to start with X. Next I went to B, which is up here, and that Y, angle Y corresponds to B, so we'll go Y next. Z is the one that's left. So triangle ABC is similar to triangle XYZ. And again, this symbol right here just means similar. Now, that is a lot of information to figure out in order to see if triangles are similar. And we don't always have all of that information when we're looking at two triangles. So I wonder what would happen if all we knew were the lengths of some sides. For example, here we've got a couple of triangles. This triangle here on the right is an enlargement of this one, and right now the zoom factor is 1.5. I wonder if these triangles are similar. So again, I wonder if all of these side lengths give you the same ratio like we know they do right now. That ratio is 1.5. Do the angles also have to be the same? In other words, is the information that we have right here just that the angles all, or the sides all give you the same ratio, is that enough to say that the triangles are similar? Well, let's see. Let's find out what the measures of all these angles are. Now, if all these corresponding angles have to be the same, we've got similar figures and we don't need to worry about the angles. And look at there. Those two angles are the same. That's angle A and angle A prime. These two right here are the same, 89.59. Those are these angles here at the top. And the 28.71s, those are the same also. Those are these angles on the right. So if it turns out that if all we know about two triangles is that the corresponding sides give you the same ratio, they have to be similar. And you know, we can change the zoom factor if you think that'll make a difference, but it doesn't. These angles are still the same. We can even change the lengths of these sides, and yeah, the angles are going to be the same, but you still got pairs of angles that are the same. 81.7, 43.43. Let's change this one. Zoom factor is still the same. Okay, the ratio of the sides is still the same. So are the corresponding angles. So let's go back to our paper. What did we just figure out? Let's say we had two triangles, 3, 5, and 6. And another one that was 6, 10, and 12. So really the question is, are those similar? And we just saw that if these sides give you the same ratio, then they are similar. So let's check those ratios. Let's go 3 over 6. 3 and 6 are corresponding sides. We make a ratio. That's 1/2. You know what? I switched these around, didn't I? These two, 5 over 10, those two correspond, and that also reduces to 1/2. 6 and 12, those two are corresponding, and those reduce to 1/2. So what we're saying here is, so these triangles have to be similar. So let's write that out. If all 3 pairs of corresponding sides give the same ratio, then the triangles are similar. We don't even need to know about the angles. If all we know is that all these sides give the same ratio, we know the triangles have to be similar without knowing anything about the angles. Now, if you're asked to explain your reasoning on a problem about how you know, for example, that these are similar, this is a lot to write. So usually in this class, we will kind of summarize this as side, side, side. And that symbol is similarity. So all this right here means is this sentence that we just wrote. So if all 3 sides, or pairs of sides, give the same ratio, then the triangles are similar. But what if we don't know the lengths of any of the sides? What if the only information we have is about the angles? Can we then say that the triangles are similar? So here are a couple of triangles, and all we know about these triangles is that all 3 pairs of angles are the same. That's all we know. We know these 2 red angles are the same, these 2 blue angles are the same, and these 2 green angles are the same. The question is that enough for us to conclude that these triangles are similar without knowing anything about the sides? I don't know yet, but let's check the lengths of the sides and see if they give us the same ratio. Well, looky there. They all give the same ratio, in this case 2.02. Let's change the triangles a little bit. Let's change these angles and see if that changes anything about the ratios. They're still all the same. No matter how we change these angles, those ratios are still always going to be the same. So it turns out if all we know about 2 triangles is that their angles are the same, then those triangles have to be similar. So let's see that in action here. So let's say we have two triangles. Let's say those are 90. Let's say this one's 60 and that one's 30. If all we know about those two triangles is the angles, and those corresponding angles are the same, so we got 90 and 90, 60 and 60, 30 and 30, then those triangles have to be similar. So let's write that out. If all of the corresponding angles are equal, and the two triangles are similar. Now again, that's a lot to write. If I asked you to justify why two triangles are similar and you were going to use this, it would take a while to write all this stuff out. So usually what we do is we simplify it, and we call this angle similarity. Okay? Angle similarity. Just means that if all the corresponding angles are equal, then the triangles are similar. Let's take a look at one more. Let's take a look at an example, see if we can apply this. So here are a couple of triangles. And we want to know if those triangles are similar. So the question is, are we going to use the sides like we did in this problem? Side similarity. Are we going to use the sides to show they're similar? Or are we going to use the angles like we did here? Well, it depends on the information we're given. In this problem, we're only given information about the angles. So here we're going to use the angles. Now, in order to use those angles, we've got to know that all three pairs of those angles are the same. So we know that angle J and angle G are the same, but this one's 25 and that one's 68. Does that mean that those triangles aren't similar because the angles aren't the same? Actually, it doesn't, because we're missing some angles right here. Let's find these angles. Measure of angle I. Now the angles in a triangle, they have to add up to 180. So if you're finding a missing one, we'll go 180 minus 68 minus 87. And if you have a calculator handy, you would be able to check this, but that is 25 degrees. So it turns out that this angle right here is 25 degrees. Oh, look, both of these triangles have a 25-degree angle. Wonder what angle E is. Let's look for angle E. Measure of angle E. Again, the angles in this triangle have to add up to 180 as well. 180 minus 25 minus 87. I'll give you one guess what that is. You probably guessed right. It is 68. Check it on your calculator if you wish, but that angle is 68 degrees. So are those triangles similar? Yes, they definitely are. Now, do we really need to check all three angles? Before I found this one, did we really need to check it? If we knew that these two are 87 and these two are 25, wouldn't these two angles have to be the same? Because to find them, I would subtract these two from 180. I would subtract the same two numbers from 180 to get this one. So really, we don't really need to check all three pairs of angles. If you have two pairs of angles that are the same, then those triangles have to be similar. And that's why in this other example, that we only put angle similarity, because you only need two pairs of angles in the triangle to be the same. Okay, only 2. You don't need to check all 3. Okay, so only 2. That is it for today. Hope you guys have a great evening. See you tomorrow.